clubs shown at the table. What expression should the cell evaluate in order to find the total number of boys? Well, if you want to find the total number of boys, just add these three together, as you can see right there. Now 17 plus 28 plus 13. Okay. We could make this a commutative property, and you know that we could just change them around, 17 plus 13 plus 28, and it would all equal the same. The sum would be the same. Explain how you can use properties of numbers to make the expression easier to evaluate using mental math. Okay, how can we use properties? Well, boys and girls, if you actually take a look at 17, right, and you look at 13, you know those two will make a very friendly number, right? Because you take the 3 and add it to the 7, it makes 20, and then you take the 10 remaining and it'll make it 30. So actually, if you use associative property, right, you can put the 17 and the 13 in parentheses, add those two to make 30 plus 28. So as you can see, I group 17 and 13 in parentheses plus 28, which is going to equal 30, right? This is 30 plus 28. So this could be written in the second line, as I'd like to do in class. The only reason I did it in one line is for the lack of space. But this would be the first line, this would be the second line, and this would be your total. So you can see I grouped these two to give me 30 plus 28, right? And then I have 30 plus 28, which equals 58. And this would be easy to work with because 3 in the 10th place plus 2 in the 10th place is 50 plus 8. Okay? So this would be associative property. Please copy it down as a key answer. Number 49. The Center of Wonders Science Center has the rates shown. So here we have a table with the rates for admissions, planetarium, and a 3D movie. This is kind of like a museum, right? A space science museum. Now, admission is the entrance, right? To go in. We don't know what the cost is. So we're just going to use the A from admission as our variable. The planetarium, okay, the actual museum part, costs $4.50 to enter, and the 3D movie is $7.75. Okay, so now we're familiar with the prices. Write an algebraic expression for the total cost for 5 people to get into the center, visit the planetarium, and watch a 3D movie. So we want 5 people, okay, 5 people to enter the center, okay, to enter admissions, to visit the planetarium, and to watch the 3D movie. So all 5 people are going to do all 3 things. Well, so how could we write it? I would definitely write a 5 personally. I would write a 5 knowing that 5 people want to do all 3, right? And then I would write admissions. Okay, so it's 5 times the admissions. So now I've taken care of this. The 5 people will get in. I don't know what the admission is, but I know it's going to be times 5 of them. Okay, plus, right? Plus, I can do another 5 because it's the same 5 amount of people, and then in parentheses because I'm going to multiply this total. You can add them up. And so when I add them up, 4 plus 7 is 11, and 50 cents plus 75 is another $1.25, so it's $12.25 when I do the whole thing together. So I'm going to write 12 decimal 25. I'm sorry for the mess. I just don't have as much room. And that would be my equation, because when I multiply 5 times A, I get my admissions. And when I multiply 5 times 12.25, I get the cost for the planetarium and the 3D movie for 5 people. And then I just simply add this amount to this amount when I'm done. But I can't add it yet because I still have this variable. So my final answer will be 5A plus 61.25. So this is 61.25 is the sum of these two times 5. Now this is not really an answer yet. It's simply an algebraic expression. And that's, once we figure out what the admissions is, we'll be able to multiply 5 times the admission and then add this total with this total, and we get our grand total. All right, let's look at B. If the cost of admissions to the center is $12, how much will it cost for 4 people to get into the center and watch a 3D movie? So now we're talking about 4 people. Okay, where are we? At a cost of 4 people, right? And they only want to enter. Okay, so the cost of admission for 4 people and to watch the 3D movie. Okay, so we're talking about this one and this one for 4 people. How would you do it? Why don't you go ahead and give this one a try, okay, and we'll check it in class. It's pretty much what I did up here, but now we've been given the value of A, okay? But we're not talking about 5 people anymore, now we're talking about 4 people. Go ahead and write down your answer and we'll check this one in class. Please remind me, I'm going to write check so that you write check in your book as well, and you can remind me that we're going to check this one. Okay, question C. Children get a discount of $2.50 on their tickets to the planetarium if they also see a 3D movie. So they get a discount to the planetarium if they see a 3D movie. Write an expression to find the cost of 2 adults and 2 children to get into the center, see a 3D movie, and visit the planetarium. So they're going to do all 3. They're going to go in, admissions, see the movie, and visit the planetarium. But now we're talking about 2 adults and 2 children, and they both cost different prices. So essentially we're talking about 2 different equations, 2a and 2a. The reason I did 2a and 2a is because I'm talking about 2 different admissions, okay? I'm talking about 2 admissions for adults and 2 admissions for children. And the reason I'm still writing A is because we're doing a completely different scenario. This is not the same scenario as B where it costs $12. We don't know that yet for this one, okay? So we're still going to use a variable of A. But remember, this is going to be the adults and this is going to be the children, and then we'll add it all up. Let's continue. Okay, so let's say we have 2A, 2 admissions for the adults. Well, the adults would have to pay 2 of this, right? So $7.75 plus $7.75, and 2 for the planetarium, $4.50 and $4.50. When you add 2 of these and you add 2 of these entrances or costs, you get a total of $24.50. So for the adults, it's going to be 2A plus $24.50. Okay, I'm going to close the parentheses. And I'm going to add that cost to the cost of the children. The children would be 2A plus $24.50, right, minus $5. The reason it's minus $5 is because they get $2.50 and $2.50 off. $2.50 for each ticket, and it's 2 kids, so it's minus $5. So $24.50 minus $5 would be $19.50. We write $19.50. And that is the algebraic expression, boys and girls. If you have any questions, please remind me to revisit this question in the classroom, or you can simply just watch this part again and listen carefully. Alright, now let's look at the hot questions from page 23. Hot questions. Write an algebraic expression that can be simplified using at least 2 different properties. So, commutative or associative properties. Simplify the expression showing each step and provide a justification for each step. Okay, I'll try to do that here. Let's just write a common, just a simple commutative property of addition. Let's try that. So for example, A plus B plus 10. Okay, that can be written as 10 plus 5 plus B. And there we have our commutative property, right? Our commutative property. So now it's asking for 2. So we must show a different one. Okay, so simplify the expression showing each step, provide a justification for each step. Okay, now let's write an associative one right underneath of it. So I use associative property for the next section to simply add the 10 and the 5 together and isolate the, well, not really isolate, but separate the b on its own so that I can add this mentally and I get 15 plus b. So I use, over here, I use commutative property and then associative property to group the ones that I can add together so that I can have my answer 15b. And that's my justification right there. Continuing on. Is the following statement true or false? Explain your reasoning. Okay, 15 plus 4 times 6 is the same as 15 plus 4 times 6. Well, boys and girls, this is where I want you to use your logic and let me know in class if this is true or false. Now, please use PEMDAS to do order of operation so that you do multiplication first, okay? And you let me know if this is true or false. So this one gets another check. Okay, continuing on. Megan is simplifying the expression 8 times 3 times 4 times 2 times 3. Okay? Find her mistake and correct it. Let's see. 8 times 3 times 4 times 2 times 3. 8 times 3 is 24, correct? Times 2 times 3. Well, there you go. She didn't do 2 times 3. She didn't do the 6 on this side. Okay? So then she multiplied 24 times 4 to get 96. Times 2 times 1, 92. She completely forgot about the 3. You see that? So this actually should have been a 6. And there's our mistake. I hope you saw that as well. Question 53. Okay? If you take any two whole numbers and add them together, so two whole numbers and you add them together, the sum is always a whole number. Well, that's true, right? It's always a whole number. This is the closure property of addition. Here we have another property. It's called the closure addition. So that means when you add two whole numbers, you'll get a whole number. The set of whole numbers is closed under addition. Okay, so whole numbers, add them together, you're going to get a whole number. It's closed under addition. Is this true? It's always true. It is a property. It's a rule. Now, does this apply to subtraction? Is the set of whole numbers closed under subtraction? If not, give a counter example. Well, I would say no, boys and girls, because if you subtract, let's say, a number, a whole number, by a greater, you subtract it by a greater whole number, you're going to get a negative number, and a negative number is not considered a whole number. So there you have it. No, because 2 minus 3 equals negative 1. And negative 1 is not a whole number. So the closure property for addition does not apply to subtraction. Okay, remember that, please. Question B. Suppose you had a very small set of numbers that contained only 0 and 1. Would this set be closed under addition? If not, give a counter example. So meaning, if I only have zeros and ones, let's say I just have 0, 1, 1, 0, 1, 1, 1, 1, 0, those are the only numbers, right? And this is my set. Now, would this particular set be closed under addition? Would it be closed under addition, meaning only that set could belong? Well, actually, no, because if I add 1 plus 1, I'm going to get 2. And 2 is a number higher than this particular set of numbers. So yeah, my answer is no, because 1 plus 1 equals 2. And 2 is higher than the set of number we were talking about between 0 and 1. So it is not closed under the addition. It's not close to that, meaning it's not part of it. It's not within those parameters. 2 is not a member of the set. Please write this down.